Bearings are machine parts in which other parts turn or slide. They are found in almost every type of moving machinery. Since your job involves maintaining equipment that uses bearings, you need to know how bearings operate. You also need to know how to recognize the types of bearing failures that may occur, how to remove bearings, and how to install new bearings. The two general categories of bearings are rolling contact bearings and sliding surface bearings. This unit focuses on rolling contact bearings. Bearings are found in almost every type of moving machinery, and they perform three basic functions: carrying a load, reducing friction, and positioning moving machine parts. The term load refers to the force or weight that is placed on a bearing. Different bearings are designed to withstand different types of loads. The type of load that is placed on a bearing is determined by the direction in which force is applied. This force can be either axial or radial. Let's look at an illustration to see what these terms mean. Most bearings are mounted on rotating shafts. A shaft rotates around a center line or axis. The distance from the axis to the outside of the shaft is called the radius. While individual bearings may differ slightly, a typical rolling contact bearing consists of rolling elements, an inner ring, an outer ring, and a retainer. The rolling elements in a rolling contact bearing are either balls or rollers made of specially hardened steel. In this example, the rolling elements are balls, and they are set between two hardened steel rings, an inner ring and an outer ring. These rings are often called races. In a typical installation, the outer ring is fixed and doesn't move. The inner ring is fitted to the shaft. As the shaft rotates, the inner ring also rotates. The rolling elements are held in position by the retainer, which you may hear referred to as a separator or a cage. The retainer positions the rolling elements evenly around the rings and ensures that the load is distributed equally on each rolling element when the shaft is turning. In addition to these parts, some rolling contact bearings are equipped with devices that protect them from dirt and other contaminants. One type of protective device is a shield. A shield can prevent all except the very smallest contaminants from entering a bearing. The shield is usually attached to the ring that does not rotate. Another type of protective device is a seal. A seal is similar to a shield, but it has a lip that rubs against the ring that rotates. Seals are used primarily on permanently lubricated bearings because they prevent the lubricant from leaking out of the bearing. Rolling contact bearings can be divided into two categories based on the shape of their rolling elements. The two categories are ball bearings and roller bearings. The various types of ball bearings differ primarily in the shapes of their inner and outer rings. Let's look at some common types of ball bearings. This ball bearing is a shallow groove ball bearing. In a shallow groove ball bearing, the inside surfaces of both the inner and outer rings are shallow. This type of bearing is specifically designed to handle radial loads. A deep groove ball bearing is similar to a shallow groove ball bearing, except that the inside surfaces of the inner and outer rings are deep. Deep groove ball bearings are designed primarily for moderately heavy radial loads, but they can also handle a small amount of axial load. This type of bearing is also called a Conrad bearing. This is a spherical race ball bearing. It has a deep groove in its inner ring, but the surface of its outer ring is shaped like part of a sphere. This type of bearing is designed primarily for radial loads, but it can carry some axial load. Spherical race ball bearings are called self-aligning bearings because they can adjust to some misalignment. Misalignment is a condition in which one ring of a bearing is out of line with the other ring. The shape of a spherical race ball bearing allows it to handle a small amount of misalignment. Another type of ball bearing is an angular contact ball bearing. An angular contact ball bearing has a high shoulder on one side of the inner ring and a high shoulder on the opposite side of the outer ring. This design allows the bearing to handle both axial loads and radial loads. Angular contact bearings are often used in pairs so that they can support axial load in either direction. The surfaces that contact each other are specially machined to match. If one of the pair fails, both bearings must be replaced. This illustration shows the main parts of a type of ball bearing called a ball thrust bearing. In a ball thrust bearing, the inner and outer rings are parallel to each other instead of one inside the other. This placement of the rings allows the bearing to support axial load, but only a small amount of radial load. The other basic category of rolling contact bearings is roller bearings. Roller bearings can carry more load than ball bearings because rollers are larger than balls, and they spread the load over a greater area. Let's look at some common types of roller bearings. Cylindrical roller bearings have rollers that are shaped like cylinders. These bearings are designed primarily to support heavy radial loads. Needle roller bearings are similar to cylindrical bearings, but the rollers are much thinner. Needle roller bearings can support a great deal of radial load because many of the thin rollers can be put into a bearing. Needle roller bearings are often mounted without an inner ring or a retainer. Instead, the rollers ride directly on the surface of the shaft. Because these bearings can be mounted without an inner ring, they are often mounted on shafts where space is limited. Another type of roller bearing is a tapered roller bearing. In tapered roller bearings, the rollers are smaller at one end than at the other. The rings are tapered to match the rollers. Tapered roller bearings can support both radial loads and axial loads. Barrel or spherical roller bearings are self-aligning bearings. The outer ring is shaped like part of a sphere, which allows the bearing to align itself. Barrel roller bearings are designed to handle primarily radial loads, but they can also handle some axial loads. This illustration represents the construction of a roller thrust bearing. In a roller thrust bearing, the rings are parallel to each other instead of one inside the other. Roller thrust bearings are used to support heavy axial loads, but only a small amount of radial load. Bearings are precision parts, and they must be installed as precisely as possible. How the bearing fits onto a shaft and the kind of mounting that is used are both important to the proper functioning of a bearing. The term fit refers to the tightness or looseness with which a bearing is installed onto a shaft. There are two kinds of fit: push fit and press fit. A push fit is a fairly loose fit. Usually a ring that has a push fit can be pushed into place by hand. A press fit is much tighter. More effort is needed to press the ring into place. A press fit is also called an interference fit or a shrink fit. Generally, rolling contact bearings have a press fit on the ring that rotates and a push fit on the ring that doesn't rotate. In most bearings, the inner ring is the ring that rotates. So let's take a look at some methods for mounting bearings whose inner ring rotates. One inner ring mounting method that's commonly used is lock washer lock nut mounting. In this method, a shoulder on the shaft is used to prevent the bearing from sliding in one direction. The shoulder is the place on the shaft where the shaft size changes so that a bearing can be placed against it. The bearing is installed with a press fit against the shoulder. A lock washer and a lock nut are used on the other side of the bearing to prevent the bearing from sliding in the opposite direction. The lock washer has a tab that fits into a slot in the shaft and prevents the lock washer from slipping around the shaft. Other tabs on the lock washer can be bent to fit into slots in the lock nut to prevent the nut from loosening. Another method of mounting a bearing is called end plate mounting. This method is used when the bearing must be mounted on the end of a shaft. When end plate mounting is used, one side of the bearing is held in place by a shoulder on the shaft. The other side of the bearing is held in place by an end plate. This end plate is secured by locking bolts that screw onto the end of the shaft. Another method of inner ring mounting is called eccentric cam mounting. In this type of mounting, the bearing's inner ring is wider than usual. One end of the inner ring has a projection that is slightly off-center from the rest of the bearing. This projection is called an eccentric cam. A locking collar fits over the cam. The shapes of the cam and the locking collar cause the inner ring to be squeezed against the shaft when the locking collar is turned. Another type of inner ring mounting is tapered sleeve mounting. With this method, the inner ring of the bearing is not mounted directly on the shaft. Instead, a slightly tapered metal sleeve is placed on the shaft first. Then the bearing is slipped over the sleeve. The inner ring of the bearing must have a matching taper so that the ring will make full contact with the sleeve. The bearing and the sleeve are secured to the shaft with a lock nut and lock washer. As the lock nut is tightened, it drives the bearing up the tapered sleeve. This causes the sleeve to tighten down on the shaft. The last type of mounting we'll look at is mounting a bearing without an inner ring. In this type of mounting, the outer ring and rolling elements slip over a specially hardened shaft. The rolling elements are in direct contact with the shaft, which acts as the inner ring of the bearing. This kind of mounting is often used when there is not much space around the shaft. Bearings are usually enclosed in housings. The housing is the part that surrounds a bearing and holds it in place. In order to support the bearing, the housing must be able to handle the types of load that the bearing is subjected to. The load is usually transferred from the shaft to the bearing to the housing. Most housings contain lubricant for the bearing, and they also prevent dirt and other contaminants from getting into the bearing. Bearing housings are divided into two types: pillow block housings and built-in housings. Pillow block housings are located outside the machine casing and are separate from it. In some cases, the pillow block housing holds the end of the shaft. In others, the shaft passes through the housing. Pillow block housings can be either solid or split, and they come apart in different ways. Some solid pillow block housings have a removable cover. Once the cover is removed, the housing can be moved out of the way and the bearing can be taken off the shaft. With a split pillow block housing, the top of the housing can be taken off. The shaft can then be lifted out so that the bearing can be removed. A built-in housing is actually part of the machine casing. In many cases, the shaft and the bearing are completely contained within the machine. To reach them, the casing must be taken apart. Built-in housings may also be solid or split. The solid types of built-in housings usually have removable end caps. Removing the end caps allows the bearing and the shaft to be taken out of the machine so that the bearing can be worked on. With a split-type built-in housing, there is a joint in the machine's casing that must be taken apart to get to the bearing. This allows the shaft and the bearing to be lifted out so that the bearing can be worked on. Bearing housings can be built either to allow a small amount of axial movement or to completely prevent axial movement. A housing that allows a small amount of axial movement is said to have a floating bearing. A housing that prevents all axial movement is said to have a fixed bearing. Both types of housings may be in the same machine. A shaft usually has several bearings spaced along its length. As a rule, only one of these is a fixed bearing. The others are usually floating bearings. All bearings need to be lubricated in order to reduce the amount of friction and wear that occurs during normal operation. Rolling contact bearings are usually lubricated with either oil or grease, and that's what we'll be focusing on during this part of the lesson. As we do, keep in mind that some bearings are permanently sealed and do not need additional lubrication. Your plant's maintenance procedures should specify which bearings require additional lubrication. We'll begin with lubrication methods that use oil. Generally, oil is used to lubricate bearings installed in machines that operate at a high speed under a light load. There are several different ways to provide oil to rolling contact bearings, including forced circulation, constant level oilers, oil baths, splash feed methods, and drip feed methods. A forced circulation system is a common method for lubricating rolling contact bearings with oil. In this system, a pump supplies a steady supply of oil to the bearing. The pump sits on top of a rectangular reservoir called a sump. After leaving the bearing, the oil collects in a reservoir so that it can be pumped again. Oil filters in the system remove dirt and contaminants from the circulating oil. Coolers are also used to remove heat that the oil picks up from the bearing. Another way to lubricate bearings is with grease. Grease is generally used to lubricate bearings that are installed in machines that operate at slow speeds under heavy load, such as large circulating pumps. When adding grease to a bearing, it's important to use a grease that is compatible with the grease that is already in the bearing. Mechanics generally use one of three basic methods for greasing a bearing. They can grease the bearing with a grease gun, pack the bearing by hand, or use a grease cup. These methods are used only with bearings that are not sealed. Sealed bearings are permanently lubricated and they do not have to be greased. Many bearings that have to be greased are contained in housings that have grease fittings. A grease fitting is a small rounded projection on the housing that has a hole in it. To grease the bearing, a grease gun with a matching fitting is attached to the fitting on the housing. When this method is used, it is often necessary to remove the housing drain plug to allow old grease or excess grease to drain out as new grease is pumped in. Grease should be applied to the bearing while it is in motion to ensure that the grease will be evenly distributed. If the housing doesn't have a drain plug, the excess grease or old grease leaves the bearing through the shaft seals. In this case, it is very important to add grease slowly to the housing so that the shaft seals are not damaged. A good rule of thumb is to pump the grease gun no more than 2 or 3 times unless specific plant guidelines state otherwise. When you're installing a bearing, you may have to hand pack the bearing with grease. To do this, hold the bearing in your hand while you press grease in between the rolling elements. Make sure that the grease is distributed evenly throughout the bearing. Pack the bearing 1/3 to 1/2 full of grease. If too much grease is added, rotate the bearing slowly to force out the excess grease. Another way to lubricate a bearing with grease is to use a grease cup. A grease cup is a threaded container with grease in it that is mounted on the bearing housing. The top of the cup is turned to force the grease into the bearing. In this topic, we looked at the functions and features of rolling contact bearings and at some common types of rolling contact bearings. We also looked at different mountings and housings for bearings and saw how bearings can be lubricated. Now try some practice questions. Rolling contact bearings can last for years, but eventually all bearings fail. There are several factors that can cause bearings to fail and several specific types of bearing failures. Usually, it's possible to tell a bearing is failing before removing the bearing from the machine. Bearing failures are often accompanied by high levels of noise or vibration, high operating temperatures, and the smell of burnt oil. After a failed bearing has been removed and taken apart, other evidence of bearing failure may be seen. This evidence may include burn marks, which are blue or brown marks on the rolling elements or the rings, spalled areas, which are places where the surface of the metal has flaked away, a bent or broken retainer, cracks in the rings, and discolored lubricant. If the bearing failure is unusually severe, all of these signs could be present, but not all of the signs are necessarily present with each type of failure. Let's look at some common types of rolling contact bearing failures. One type of bearing failure is fatigue failure. Fatigue failure happens to every bearing eventually. It occurs because the bearing has worn out. Symptoms of fatigue failure may include loud noise and vibration, high operating temperature, burn marks, spalled areas, a bent or broken retainer, or cracks in the bearing metal. Fatigue failure is caused by metal fatigue. When a bearing is in operation, it is continually flexing or bending. Although the amount that a bearing bends is very small, it is significant because it is continuous. There is a limit to the amount of bending and flexing the bearing metal can tolerate. After the metal has reached its limit, the bearing fails. Another type of bearing failure is lubrication failure. Lubrication failure occurs when the oil or grease in a bearing fails to function correctly and the bearing overheats. Symptoms of lubrication failure include the smell of burnt oil, discolored lubricant, and burn marks on the rings or rolling elements. Lubrication failure can also be caused by improper lubrication. This could mean too much or too little lubricant, using the wrong kind of lubricant, mixing lubricants that aren't compatible, or using contaminated lubricant. Misalignment failure is a type of failure that occurs when one ring of a bearing is out of line with the other. The primary sign of misalignment failure is unusual wear marks on the inside of the rings. A normal wear pattern follows the center of the ring. Thrust failure occurs when there is more axial load on a bearing than the bearing can handle. The signs of thrust failure include cracked rings, a bent or broken retainer, and loose rolling elements. Thrust failure can occur for a number of reasons, including incorrect bearing selection, improper installation, and excessive installation force. Rolling contact bearings are usually installed with a press fit on one ring and a push fit on the other. Removing a bearing that has been installed with a push fit is relatively simple because it is a loose fit. Removing a bearing that has been installed on a shaft with a press fit is more difficult because it is a tight fit. The principles involved in removing a bearing that was installed with a press fit are the same, whether it is the outer ring or the inner ring that has the press fit. In this part, we'll look at two methods for removing the press fit inner ring of a bearing from a shaft. The first method is used when the shaft can be removed from the machine. This method uses a device called a hydraulic press. A hydraulic press is a machine that is frequently used to apply pressure to the parts of a piece of equipment that is being assembled or disassembled. A hydraulic press removes a bearing from a shaft by holding the bearing in place and pushing the shaft through the bearing. Let's watch a mechanic use a hydraulic press to remove a bearing from a shaft. To begin setting up the hydraulic press, the mechanic first adjusts the height of the bed. Then he places table plates on the bed. Next, he sets up the shaft in the bed. The mechanic lines up the shaft so that the table plates are supporting only the bearing's inner ring. This is important because if too much stress is placed on the outside ring, the bearing could be damaged. He also checks to ensure that the ram is positioned directly above the shaft. Next, the mechanic inserts the shaft protector between the shaft and the ram. After the shaft and the bearing have been lined up, the mechanic closes the pressure release valve on the hydraulic pump. Then he pumps the handle to begin applying force to the press. As the shaft starts to move through the bearing, he watches the bearing to make sure that it does not jump off its supports and to make sure that it is not cocked. If the bearing is cocked, it will jam on the shaft. As the shaft is forced straight down through the bearing, the mechanic holds onto the shaft with one hand to prevent it from dropping. The second method we will look at to remove a bearing uses a bearing puller. A bearing puller is a portable device. It is generally used to remove a bearing from a shaft when the shaft can't be removed from the machine. Before using the bearing puller to remove a bearing from a shaft, the mechanic applies penetrating oil between the shaft and the bearing. This oil makes it easier to remove the bearing. Then he sets up the bearing puller jaws behind the bearing so that they rest loosely against the shaft. Next, the mechanic hooks the side rods behind the jaws. Then he makes certain that both rods are aligned correctly on the strong back. In this example, the mechanic places the lead screw into an alignment hole in the shaft. Then he tightens the lead screw. He checks the position of the jaws to make sure that they will only push against the inner ring. A good way to check the jaw position is to tighten the puller and then turn the bearing's outer ring. If the outer race can move freely, then the jaws are positioned correctly. Next, the mechanic uses a wrench to tighten the lead screw and draw the bearing off the shaft. He is careful not to cock the bearing. If the bearing is cocked as it comes off the shaft, it will jam and the puller will have to be readjusted. The mechanic continues pulling until the bearing is loose enough to be removed by hand. After the failed bearing has been removed from a shaft, the mechanic cleans the bearing with an approved solvent to remove grease and dirt. Then, after the bearing has dried, he inspects the rings and rolling elements. He turns the bearing slowly to determine whether there is any stiffness or binding when the rolling elements turn. He also checks for signs of failure such as spalling, burn marks, cracks, dents, and pits. In this topic, we looked at some causes of rolling contact bearing failures, and we looked at specific types of failures and signs that accompany each type. We also looked at 2 ways to remove failed bearings. To test your understanding of what we've covered, try answering some practice questions. Bearings that fail must be replaced. In this part, we'll watch a mechanic prepare to install a new rolling contact bearing. The mechanic begins by carefully removing and cleaning the damaged bearing. After a bearing has been removed from a shaft, it should be handled carefully. It should not be left where it will get dirtier, and it should not be rotated, banged around, or dropped. Handling the bearing carelessly will only make the task of determining why it failed more difficult. In order to properly inspect the bearing, the mechanic must first clean it. In this example, the mechanic cleans the bearing with an approved solvent to remove grease and dirt. Then, after the bearing has dried, he examines the bearing for signs of failure. He turns the bearing slowly to determine whether there is any stiffness or binding when the rolling elements turn. He also checks for signs of failure such as spalling, burn marks, cracks, dents, and pits. If the bearing has been damaged due to misalignment failure, lubrication failure, or thrust failure, the problems that caused the failure must be corrected. In this example, the bearing has simply worn out. The mechanic then selects the correct type of replacement bearing according to the manufacturer's specifications. He checks to make sure that the part number of the bearing specified by the manufacturer is the same as the part number on the replacement bearing. In this example, the mechanic's next step is to pack the new bearing with grease. Before installing the bearing, the mechanic measures the diameter of the shaft and the diameter of the inner ring with a micrometer to make sure that all the parts will fit together correctly. When all of these preparations have been completed, the replacement bearing can be installed. New bearings must be installed correctly in order to work properly. In this part, we'll look at 2 common methods of installing rolling contact bearings. One method uses a hydraulic press, and the other method uses a tubular drift. We'll start with the tubular drift method. A tubular drift resembles an ordinary length of pipe. The drift should be made of a soft metal to prevent damage to the bearing or the shaft. The inside diameter of the drift must be slightly greater than the inside diameter of the inner ring of the bearing that is being installed. If the drift and the inner ring were exactly the same size, the drift would jam on the shaft. The outside diameter of the drift must never be so large that it touches the rolling elements or the outer ring, because a drift that large could damage the bearing. When a tubular drift is used, the shaft stays stationary and the bearing is forced down the shaft. This method is generally used when the shaft can be removed from the machine and placed in a vise. If the shaft is left in the machine, its other bearings may become Brinelled. The tubular drift method is both simple and efficient. Let's watch a mechanic install a bearing using a tubular drift. First, the mechanic secures the shaft in a vise. He then lubricates the part of the shaft that the bearing will slide over. This will make it easier for the bearing to slide onto the shaft. Next, the mechanic pushes the bearing onto the shaft by hand as far as it will go. He then places the drift over the shaft, checking to make sure that it does not touch the rolling elements or the outer ring. Then the mechanic uses a mallet to pound the drift against the bearing until it is in the correct position. When the inner ring of the bearing is flush against the shaft, the mechanic installs a lock washer and a lock nut. Another common method of installing a rolling contact bearing uses a hydraulic press. A hydraulic press is frequently used to apply pressure to the parts of a piece of equipment that is being assembled or disassembled. With a hydraulic press, the bearing stays stationary and the shaft is pushed through it. When a hydraulic press is used to install a bearing, the first step is to set up the press. First, the mechanic adjusts the height of the bed to fit the length of the shaft. He then places the table plates on the bed. Next, he positions the bearing on the table plates so that only the inner ring is supported. Next, the mechanic lubricates the shaft. The shaft is lubricated before it is placed in the bearing so that it will slide into the bearing more easily. Then he places the shaft in the bearing. The mechanic checks to make sure that the shaft is lined up directly under the ram. Then he places the shaft protector on the shaft and partially lowers the ram into position. Before operating the press, the mechanic checks the whole assembly again to be certain that everything is lined up properly. The mechanic then operates the press. He watches the shaft carefully to make sure that it moves smoothly into the bearing. If the shaft does not move smoothly into the bearing, the mechanic must stop the press because the bearing might be jammed. If this happens, the mechanic must correct the problem and then recheck the alignment of the bearing, the shaft, and the ram. He can then restart the press. After the bearing is on the shaft in the correct position, the mechanic stops the press and inspects the bearing. He checks to make sure that the entire surface of the inner ring is touching the shaft all the way around. The mechanic then removes the bearing and the shaft from the press. In this topic, we saw how to prepare for installing a new rolling contact bearing, and we looked at some installation methods. To test your understanding of what we've covered, try answering some practice questions.